Well, thank you very much. Today, what I want to do is present to you CORE's solution to helping government and private sector extracting business rules from typically from large legacy-based applications, things like written in COBOL and Java, .NET, and transform those to documents that can be used by the organization to validate the business application. Our presentation is to Mr. Alex Benet, the CIO of Government of Canada, and myself. My name is Garry Whitworth. I'm the CIO of Core Migration. So without further ado, our presentation will run about 40 minutes. Go through a little bit about CORE, the benefits of automating the extraction of business rules, the anatomy, what is a business rule and why would we want to extract that, and what's the value of that to me as a CIO, how can the business rules be used, and then finally we'll go into a technical demonstration of a couple of Government of Canada business applications, specifically at ESDC and at Transport Canada. So about CORE, I won't go through every slide, but or point in this slide, but we have over 19 years of experience. We started in 1997 on a large project with the Government of Canada. We do have a solid track record of project management and delivery, and we're on time, on budget, and typically our projects are fixed price, fixed timeline. And I'll talk to why we're able to offer that to our clients. We have proven technology that we've been perfecting over the last 20 years. We started migrating legacy applications to .NET and Java, but more recently we've been into extracting business rules from these same applications and generating UML and various artifacts that can be used by the organization to understand what that business application is doing and what the rules are within it. We, of course, can also migrate many languages to either .NET or Java, Oracle, SQL Server. Some of the benefits of application modernization, that is transforming it from, say, a COBOL to a .NET platform, is it does minimize retraining to both end users and development staff. And of course, complete data conversion services are included in mostly all of our projects that we undertake. So from a project delivery perspective, we've delivered projects on numerous operating systems, from AS400 to Windows and Unix and VAX VMS. We have expertise in modernizing and extracting the business rules from numerous languages. These are just a few listed here. Database file systems, we've encountered numerous of these on various operating systems, ISAM-based structures, image, network type databases. From an application vertical perspective, we've performed work on many verticals, including aircraft maintenance, for example, insurance, investment portfolios, voter management, and many more. Our tools have processed millions of lines of code that have gone through the tools, either through a application migration project or through a business rules extraction project. And some of the current projects that we have ongoing are ASP.NET, some HTML5, Angular, and from a business rules recovery, Power Builder, Powerhouse, COBOL projects are ongoing as I speak. Some of the languages we support, and this is a list. I'm sure there's additional that have been added since this slide was put together, but we do offer services against all of the languages listed here on this slide. Really, CORE takes an enterprise transformation approach when performing work for our clients. Typically, our clients are in the space on the left here, where they have many numerous vertical stovepipes, we call them, or smokestacks of business applications. Typically, these are written in different technologies, talking to different databases. For instance, we have a customer application here, an equipment maintenance application, a finance application. What we offer to our clients is the ability to parse, using technology, all the business rules and out of these stovepiped applications, and load them into our repository. The way we go about doing that is we have language parsers that interface to the source code that our clients give us. We parse the programs. We create an intermediary step. This is typically an XML-based language that then get loaded into our repository. Once the application or applications are inside of that repository, they are language neutral, and what is left behind is the business rules that were made to construct the application. The user interface widgets, the structures, data structures used, the algorithms and business logic that are used by these business applications to validate and process data. And then we have our forward engineering toolkit, which reads our repository and reconstructs either the target language or reconstructs the business application in a form of a UML business flow work diagrams. So just in more detail, that's what we just discussed. So that being said, we are using technology to do this work. What we're seeing in the marketplace is many companies hiring business analysts and hiring developers to document these legacy systems. And the reason they're having to document them is typically some of these systems are 20, 30 years old, and the people that worked on them originally are now retired and no longer available. So what we're seeing in the market is newer people are having to understand what these business systems are doing, and that's where we fit in. We're able to automate the extraction of business rules and reduce, we call it the grunt work, or the reading of code by a human and documenting of code by a human, and we accelerate that process by using technology and using our parsers and using a machine to generate. And by using that machine, we become repeatable and consistent, and that is a very important concept. You can give us code 3 months from now and we can run it through our tools and you will get the exact same result. There is no subjectivity in our process, and it is repeatable and consistent. Our process really abstracts the rules and the logic within the application into a format that is easily readable and understandable by a human, by a business analyst, by a end user, and by the developer. By automating that work, it certainly lowers the cost of developing and modifying the business rules, because most of the heavy lifting is being done by technology. There is still an organic component of business analysts that are required to validate the end result and to augment the information by working through JAD sessions with the end user communities. The process externalizes the rules so that they can be shared by multiple applications, and also our technology separates the business applications into 3 layers, or typically the database, business logic layer, and presentation layer. So making that leap to the newer technology is less burdensome. So some of the typical reasons for extracting a business rule that we've seen is some clients are looking to rewrite and re-engineer it from the ground up, from scratch we call it. Why would I need business rules? Well, it would be really good to know what the current legacy system is doing and understanding what the users want and don't want so that it can facilitate that rewrite effort. We're seeing business rules being used for package replacement, like Microsoft Dynamics, where the business rules can be extracted and moved forward into Microsoft Dynamics. And then, of course, other companies are using business rules to modernize and maintain, move the business application to a newer technology. We call this lift and shift. So we're essentially lifting the logic and the business rules from the legacy platform and moving it to a web-enabled .NET compliant application. Some of our clients are also asking for thick client, which is also an option that we allow. So key concept for IT managers is the most single critical factor in modernizing and re-engineering rewrite project is that the more we reuse from the existing legacy business application, the lower the cost, the lower the time, the lower the risk. We're not starting from a blank page, and often the rules that are inside of these business applications haven't really changed over time. The only thing that has changed is typically the technology that these business rules were written in or operate on. So that's a key concept. The single most cost-effective and accurate source of business requirements is always your legacy application. So what we're taking is we're taking production code and we're running it through our engine to generate the specifications of the system. This will be the most closest truth of the rules. It'll supersede any documentation that's been created just by the fact that documentation quickly becomes stale if it's not kept maintained. So that is an important idea to consider. How should you think about business rules? Well, if we look at applications from a business rules perspective, it's really the only perspective that has survived all applications, all languages, and all platforms. And what we mean by this is that if we go back in time to the 1980s, back then prevalent language technologies were COBOL and PowerHouse and these type of languages. The developer may have built a rule in that business application, said if a customer type is a type C, then do some action. The 90s came along. This was typically the power builders. So some of those COBOL and PowerHouse applications got transformed to Power Builder. But again, the business rule, if customer type equal a C, still stayed the same. It was just moved into the newer technology. And then if we go into the 2000s, this is around VB, 2010 into .NET. So really what we can see here is that the technology has changed, but the business and the data and typically the business rules have stayed the same. Only if been a major shift in the business, typically this is what we're seeing on all projects that we work with. So most of the organizations, have rules that have been in place since the beginning of the organization. In some cases, some of our clients have been running these systems for up to 40 years. A business rule example, if a customer type is a government agency, then give a 10% discount. That's a business rule that would be programmed in the business application. Another one might be if the quantity on hand falls below the reorder point, then create a purchase order. Those are business rules examples, and those will stay the same regardless of the technology that is being used. Business rules span the lifetimes of multiple systems because they're business constructs. They're not system, they're not technical construct, but business constructs. And typically the business rules belong to the business, so they should be able to read and understand them. And that's some of the benefits of what our technology produces. Anatomy of a business rule, well, we use parsing technology to parse through all the source code. So if the source code doesn't compile, our technology will flag it as an error and we will not process it. So all programs that enter into our repository need to have compiled in the original technology. We build parse trees to identify business rules. Typically, we're finding business rules around if constructs. So if a certain condition exists, then a certain action is taken. Those are typically abstract constructs of a business rule. So extracting business rules, for example, some of our clients have given us this at the top, which is actually an Oracle Forms piece of code, which is very cryptic and hard to read, but inside of that blue area is actually a business rule that our tool was able to extract into something that's much easier to read. Business Rule 72, you cannot delete a master record. If we found a customer, then you cannot delete the master record when matching detailed records exist. And then we also transform that into UML type flows and diagrams so that we can look at large logic chains much easier this way, and especially end users as well. So if we look at this slide and we look at condition 1 and we look at condition 2, we can see that from a structural point of view they look exactly the same. I mean, if I wasn't looking at the words, I couldn't distinguish one from the other, but one is a business rule and one is not. And I always throw this question out to my audience and they always get it because it's common sense that condition 2 is the business rule. So if the customer is a wholesale customer, then we give them a 10% discount. So this is an important feature, and what our technology is doing is we are pulling out the conditions on the right that are more prevalent to the use of business analysis. So our tool is able to identify those conditions that are business rules, and we do that primarily by identifying the constructs that are being used inside the conditions to identify if tables, database tables and database columns are being used in the expression, and typically if that's the case, then that is triggering a business rule. So we call this condition on the left, if window.resize equal to true, we call that a technical rule. It really only exists for the programmer to resize the window, but from a business rule perspective, it has no bearing on the business. So this is what our technology is also helping to do, is not only document what's inside the systems, but flagging the conditions that are the most important ones that business analysts can look at rather than looking and spending their time looking at technical business rules. So over the last 19 years, we've had the opportunity to analyze many projects and applications. A typical application that we've seen is typically around 1 million lines of code. And typically these amounts of lines of code boils down to about 30,000 business rules on average. So if you were going to rewrite your application from scratch or replace it with a package solution, you still need to understand what those business rules are doing. And there's a couple of ways that this can be accomplished. One way would be to do it manually and to review the code and to document all the business rules with some developers and a business analyst, and then work with the users to identify which ones are good and which ones aren't good. So if we can imagine ourselves as Steve here on the left, and he's been tasked with making sure that we've captured all the business rules from the system, and he says, "Hi, this is Steve in IT. Do you have any time to define 30,000 business rules with me?" And poor Elaine on the right hand side looking at her watch, and Steve saying, "Well, based on our analysis, most of the rules that we have now." And Elaine, of course, "Well, why don't we just use those?" And I mean, the other way to do this is to use automation. and to work with something and not with a blank page. So right now what we're going to go into is a bit of a demonstration. I'm running at 20 minutes now, probably another 10 minutes. So what we're going to show you now is a couple of applications that have actually gone through our process. So we've already parsed it, we've transformed the data model, we've transformed the application metadata, and we've generated a UML diagrams and UML representation of these business applications. Okay. So the first one that I want to talk about is ESDC. ESDC is came to us with the National Injury Compensation System, which is called NICS, and asked us to look at it and to modernize pieces of it, as well as to document certain processes in it to validate the technology. So the first thing we did for ESDC was to do an application portfolio assessment. So ESDC came to us with a number of Power Builder applications for compensation and for other sorts, and they are running on Sybase. So they wanted to look at modernizing and what would be the effort involved in modernizing these business applications to a .NET SQL Server based technology. So some of the results of our, we produced a lengthy report, but some of the metrics were, it's a Power Builder 12.5, connects to a Sybase database. The system was in production first year in '96, has 100 users, 50 concurrent. Right now it's down to half an FTE to maintain that application, and the target language was VB.NET and SQL Server, and the .NET was crafted to work at Shared Services Canada using their wet templates and various frameworks. So just briefly, these are some of the outputs of our technology. We'll come back and we'll outline how many lines of code. So from looking at NICS, we can see that it is made up of 169,000 lines of Power Builder code. This is how we base our estimates, and our pricing is primarily based on lines of code. And again, as I mentioned, our work is fixed price, fixed timeline, guaranteed to you until satisfaction. So this was the breakdown of NICS. We could look at it. We did some looking at consolidation of the English and French components, and we found that if we were to consolidate them into a single, in most cases a lot of the processes were duplicated, one in English, one in French. With the new technology, we'd be able to consolidate them and reduce, in effect, 56,000 lines of code, which is a substantial amount from a maintenance perspective, and therefore costs and time to modernize. Talked about this. The business rules extraction. So what our tool does, and I'm going to flip over to that now, is it is used to read the Power Builder code, read the Sybase databases, and to produce documentation that end users can use. So we are going to go over to ESDC, the NICS business application, and you can see here what we see is our overview framework. So we read the Power Builder code, and we generated this National Injury Compensation System model. It's all HTML5, capable of running on numerous devices, including browsers and cell phones and tablets. It's very easy to use. We always separate the applications into a database design and an application design. So we can come over and look at the database design of NICS, this specific area of the system. We can zoom into a logical view, or we can zoom into the structure. We can see the various tables that are being used by the system. More specifically, we can see that we have a claim recur table. We can see how to link the table from claim recur to ICS employer. So right away, we used completely tools to reverse this diagram, which we use to document the data model. And often, once you understand the data model, you're that much further ahead of understanding the business application. So we can, zoom into our claims table, and we can see that there are 4,069 claim records. We can drill into that table and see the number of rows. We can see the various columns that make up that table. We can see the various keys. We can see how this table is related to all the other tables it's related to in one viewpoint. And then we can also see here where this table is used in the business application. So we can see that ICS claims is a very important table in this business application because it's linked to quite a few structures and various things. So as expected, this is a hub in that data model that would certainly be an important component. We can look at other areas in the data model, but and then of course flip over to the structures. So once we understand the data model, then we're able to go into the business application. What this is a representation of the business flow in the NICS application. It has a login page that once the user gets through the login page, then they're giving various options. This is a file menu or drop down. The one I want to look at today is claims processing. This was the one that ESDC asked us to look into. An operator opens a claim. The first thing they do is search for the claim to see if it's been processed. They get search results, and in this search they're able to search by workers' compensation file number, by HRDC file number, and by other concepts like surname and given name. And this was all extracted from the code, so we can very quickly see what is being used to search by. We can go to the view. Once the user searches and brings up a screen, they come to the main claim master screen, and we can see all of the processes that are linked to that claim master. I can drill into claim master. We can see here our breadcrumb trail, where we've been. We can see the screen layout of that screen. We can see the tables referenced in that screen. We could drill onto a table and inspect it and understand it a little bit more. Other things we can do is we can see where this is referenced by other classes in the system. So not only are we cross-referencing the data model, but we're cross-referencing the other components, and so on and so forth. So we have a claim, the actual claim itself, and then we start pulling into the applications and business rules. So here, this is the business rules view for a business analyst. We can see that a number of business rules were extracted. If the record type is a claim, then the HRDC file number cannot be changed. HRDC file number is mandatory for claims. And we can see by drilling down further, we can see some of the business logic flowing here. So if ICS claim record type is equal to a C, then we disallow a change. We can keep looking in. If the supervisor level is an S1, then we allow change. And we pull out comments as well, as comments are found to be a very rich source of information. So if the supervisor level HRSD file cannot be changed, otherwise it is protected from update. and so forth and so on. So by using this website and this extraction technology, rather than start with a blank page with our end users, we're able to sit down with them and go through this and validate that these are still the same and still required in the new system. And then once we've validated, we're most of the way there, because understanding what the end users really want is very important. Here's a business rule that I'm looking at here. Is very interesting. If a claim is a 1 or a 3, and if the injury date was changed, and if the injury date crosses April 1st, 1998, and the supervisor is less than S1, then you must be a supervisor to change the injury date over the April 1, 1998 boundary. And the reason for that was that a ruling came down and some claims were grandfathered before April 1st, 1998. And that's the reason for that business logic. So we could actually validate with that with our users. Is that still the case? Is that still true? And if so, make sure that it gets addressed in the new system. Okay. So I mean, at a high level, this is really what the technology is about. What I'd like to show you next is another application that we're working on for Transport Canada. As you can see, the same look and feel exists for this system. This is called the Port Warden system. It is for the Marine Group. Marine are responsible for the safety of all vessels on Canadian waters. And this system specifically is written to perform safety inspections on ships that come into major Canadian ports. The system that we were given was written in Microsoft Access, and the data was inside Microsoft Access. And again, we used our tools to read both the data model as well as the business application code to generate what I'm going to show you next. And everything here was automated using tools. Similar idea, we can see the Port Warden database. I always like to zoom in to the Port Warden, so we have ports. Again, everything you're seeing here was extracted by tools. We used the foreign key relationships in the data model. We can also use ERWin inputs to our process. We are not a data model company, but we do like to represent the data model in the tool just so that it's easily navigatable by the people that are using these rules engine here. So we can see that we have ports, we have agents for a port, we have inspectors at a port, we have clients at a port, and then we have accounts. So these would be ships that are coming into the port, and various inspection fees for various ships coming into the port, and then we have ships as well. Okay, so let's close this, and we will one moment. We will come back to look at the application view. Port Warden is a access application. So the first thing we can see is our menu navigation. We can create a new account. A new ship has come into the port that we've never seen before. We're going to do a safety inspection on it. We can look at the main menu, see that it has a ship list. We can create new ships. We can see our survey sheets that are required to go through with the owners of the ships. We can click on the main menu and get a sense. So this is the main menu of that application. We can again see the tables that are referenced inside of this form. So of course we have ports, some validation, and again business rules are being extracted. So here, if if the program could not find a port table, typically probably would be a validation system setup concept. We can come back to and look at our tariff accounts. This is when they create a new tariff account, it'll show us the various screens. This is the first tab of that form. We have the green tab, the timber deck tab. There's if the timber deck is being used on the boat, then there is more stringent checking of that timber to make sure it's safe and sound. Screenshot number 4 is our concentrates that were found on this ship, and screenshot number 5 is the any special notes. We can see, this form is the heart of the system, and you can see that it is related to many different structures in the data model, including various queries, and then the business rules that we've pulled out for this particular application is similar to what we've seen from before. So when they do a post update, after they've updated, various queries are run, and we can see what these queries are doing in the application. This application specifically was compiled, and access to source wasn't available, so we had to decompile the application to pull out these business rules. That's not always the case for us. Most of the times we're giving source code to work with. So in a nutshell, this is really what we wanted to talk to you about today. We believe we have a very solid framework and application that can be used by all government departments in Canada to accelerate the extraction of business rules. This will not only accelerate the timeline from which to do it, because we're not using primarily humans to do the work. We're using technology validated with humans who are doing the organic validation of the rules inside the application. Thank you very much for your time today. I'm a little bit under the 40 minutes, but we would be more than happy to come in and demonstrate this to you at a slower pace and show you the tools actually generating the business rules, show you our process, and take it from there. So thank you very much, and we do look forward to hearing from you. Have a nice day. Take care. Bye-bye.